So the next topic we have in hand is quartiles and percentiles, so which is also coming under median. So quartiles first. So quartiles are nothing but they are measures, which divide the data into 4 equal parts. Quarter means 4 equal parts. So it is nothing but it is a measures which divide the data into 4 equal parts. So each portion contains equal number of observations. So 4 equal parts would mean each observations or each portion contains equal number of observations, and there are 3 quartiles denoted by Q1, Q2 and Q3. So the first quartile denoted by Q1. So Q1 is the first quartile, and it has 25% of the items of the distribution below it. So it has 25% when it comes to Q1, first quartile, of the items of distribution below it, and 75% of the items are greater than Q1. So 25% of distributions are in quartile number 1 and 75% are above quartile number 1, first quartile. The next one, second quartile, is denoted by Q2. So our median has 50%. So Q2 is also known as median, and it has 50% of items below it and 50% of observations are above it. And the third quartile is Q3, and it has 75% of items of the distribution below it and 25% of the items are above it. So that is Q3, third quartile denoted by Q3. So Q1, Q2 and Q3, all these three denote the two limits within which central 50% of the data lies. So Q1, Q2 and Q3, they denote the two limits within which, central 50% of the data lies. So that is about quartiles. So the next topic is percentiles. So what does percentiles do? Percentiles divide the distribution into 100 equal parts. Quartile, it is 4 equal parts, but when it comes to percentile, it is dividing data into 100 equal parts. So you can get 99 dividing positions denoted by P1, P2, P3, P4 and P99, and here P50 is the median value. So what does percentiles do? It divides the distribution into 100 equal parts. So for example, if you have secured 82 percentile in a management entrance examination, it means that your position is below 18% of total candidates. So if a total of 1 lakh, so for example, you scored 82% in a entrance examination, which means that you are in a position where you are below 18% of the total candidates that is appearing. So percentiles divides the data into 100 equal parts. We shall see how we compute or how we calculate quartiles, or calculation or computation of quartiles being done with the formula. So calculation of quartiles. So the method for locating the quartile is same with that of the median in case of individual and also discrete series. So the value of Q1 and Q3 can be obtained by the following formulas here. So to find out Q1, you use this formula. For Q3, you use this formula. So here example is given here. Lower quartile from the data of the marks obtained by 10 students in an examination. So this is the marks given, marks obtained by 10 students in an examination. So here it is given, in rough. So arrange this in ascending order from small to big. So quartile 1, to find out the location of Q1, you use this formula: size of n plus 1 divided by 4 item. So n is 10, number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus 1 divided by 4 item. And when you do simplify this, you have 2.75 item. So 2.75 item would mean second item plus 0.75. So be careful of this point. So second item is how much? Second item is 12 plus 0.75, and in bracket it is third item minus second item. What is the third item? Third item is 14, and the second item is again 12. So 14 minus 12. So when you simplify this, calculate this, you have 13.5 marks. So 13.5 marks. That is the lower quartile from the data, from the marks that is obtained by 10 students. So that is how you calculate quartiles. So try to find out the location or value of Q3 by yourself. So after that, we have mode. Lastly, we have mode when it comes to measures of central tendency. So mode is nothing but the most frequently observed data value. What is the item? What is the value which is occurring the most, which is occurring again and again, which has the highest number of observation, which frequently observed, which is most frequently observed data value. So mode, that is mode. For example, you have 1, 1, 2, 3, 3, 5, 4, 3, 3, 6. So this is the data given here. So mode would mean the value, the data value which most frequently observed, which is frequently observed. So 3 is observed 4 times here. So in this case, there is no other value which is occurring more frequent than 3. So 3 will be the mode in this data given here. So that is mode. So we have two methods for computation of mode, that is discrete series and also again the continuous series. And mode is symbolically represented by MO like this. It is denoted by this MO. So let us straightforward go with the computation of mode for discrete series with the help of example, numerical example. So first up, we will discuss about the discrete series. So computation of mode for discrete series. So example is given here. Variable 10, 20, 30, 40, 50 is given here, and the frequency is given here 2, 8, 20, 10, 5. So for direct discrete series, directly it is given here. Frequency here 20 is the highest frequency, which means that the mode value for all this variable is 20, because 20 is the highest. Frequency means item that is occurring, how many times and value occurs. So 20 times it is occurring. So 30 is occurring 20 times, which means that 20 is the mode value, which means the highest value of the data which frequently appeared or frequently represented is 20, because this is the highest frequency in case of discrete series. So continuous series, we can also calculate in case of continuous series. Frequency distribution model class is the class with largest frequency. Again, in case of continuous series, model class is the, or mode class is the class with the highest frequency. A class which is having the highest frequency is the model class. So we can compute this by using this formula. So L, what is L? L is the lower limit of the model class. So this is all discrete series, and continuous series would look like this. So we will have class intervals when it comes to continuous series, and we will have lower limit and the upper limit when it comes to continuous series. So formula L represents lower limit of the model class. Model class is nothing but the class which has the highest frequency. D1, what is D1? D1 is the difference between the frequency of the model class and the frequency of the class preceding, preceding the model class. What is D2? It is the difference between the model class and the frequency of the class succeeding the model class or the model value. H is the class interval of the distance. So what is the class interval? Here it is 5. So in the question, less than cumulative frequency distribution of income per month in 100 or 1000 is given here, 1000 rupees. So here it is less than 50, less than 45, less than 40. So it is in less than. It is not in the form of a continuous series. So you have to make it into a continuous series like this, 45, 50. So this is continuous. And we have already studied how to find out the frequency level here. So after finding out the frequency, you found out that 30 is the highest number, highest value of frequency, which means 30 is the model classes or mode value, and 25, 30 is the model classes. So frequency, a model class is nothing but the observation which is having the highest frequency number. So this is the model class corresponding to the 30, which is the model value mode. So correspondingly we can apply this. L is 25 because L is the lower limit of the model class. D is the difference between the model class and the 30 model class and the the value preceding the model class. And D2 is the difference between the model value, mode value 30 minus the model value succeeding after the model classes 18. So 30 minus 18 is 12. D2 is 30 minus 20, which is equal to 10. So substitute all this value. H is 5 because class interval value is 5. Substitute all this value in the formula. 25 plus 12, 12 plus 10 into 5, and the answer you get is 27.273. So that is how you compute the mode value for continuous series. Don't get confused with D1 and D2. D1 is the difference between the mode value and also the value preceding the model classes, and D2 is the difference between model value and also the value succeeding after 30. 30 is the model class or model value. So preceding and succeeding. So D1 is preceding, D2 is succeeding value of the model class with the differences. So last topic is relative position of arithmetic mean, median, and mode. So if arithmetic mean is expressed as ME, M1 as median, mode as MO, the relative magnitude of the three are given as ME is greater than M1 greater than MO, or ME is less than M1 is less than MO. So median will always be